Hey, welcome back to Math with Patrick. Today's September 10th, and we're solving problem 253 from the Daily Epsilon calendar. And the answer today should be 10 because the answers in the calendar always match today's date. So we have a parabola. Looks like this is a standard form quadratic equation. Standard form just means that we have like our quadratic term here, our linear term here, and our constant term here with some kind of coefficients or like multipliers on all three things. This parabola passes through 3 points, and I'm just going to draw a quick sketch just so I can visualize what's going on. Looks like we have a point at 0, 12, so that's going to be up here. And then we have two other points at -2 and +2, and then the y value is going to be +4. So there's my 4. Just for a sense of scale, I'll put the 8 right here. Here's -2, here's +2. And I know that parabolas have this kind of like U shape to them, and so I know that it's going to connect something like this if we were to graph the whole equation here. So we just need to write this equation and then figure out what the sum of our coefficients is going to be. So let's see. My first inclination is that I think that this is just going to be, I'm using function notation right now, f of x equals -x squared plus 12. And the reason why I'm guessing this is that this negative sign, I'm putting it here because the parabola is facing downward or opening downward. And I know that if I plug in a 0 into my function right here, this value is going to be a 0. So currently I'm imagining that the point is like right here. But of course on the parabola, the point is raised 12 units upward. So this plus 12 is kind of compensating for that needing it to be raised 12 units. And now f of 0 is equal to 12. And I'm seeing that right here where I plug in a 0 and I get the value 12. So just to double check whether this equation works, I should try plugging in the 2. So f of 2 is equal to -2 squared plus 12. Looks like that's -4 plus 12. And this is going to be 8, which poses a little bit of an issue because on the graph, when we plug in 2, we're supposed to get a 4. So I have two ideas here. Either I would need to introduce some kind of linear term into my parabola, or I would need to change the a value of my parabola. And let's investigate maybe whether or not we would need a different a value. So normally with like a very standard parabola, let's just look at like the x squared function. We would have points at 0, 0, 1, 1, -1, 1, and then 2, 4, and -2, 4. So this is kind of our standard parabola shape. And what I'm looking for, or looking at right here, is that there's this 1 by 1 kind of, I guess, right triangle, if you want to think about it this way, near the vertex. And then there's going to be a 2 by 4 right triangle afterwards. And the only way for us to kind of change the scale of these triangles is to include some kind of a value at the start there. A linear term would not change the dimensions of these triangles. So I can check what's going on in our graph here, and I can see that we go 2 units to the left and then 8 units down. And I was expecting, normally it's 2 and 4. And so the only way for me to get 2 and 8 is for me to actually change the a value and double it. So let's try this again with now a -2 x squared, and then still the same plus 12. If I plug in the 0, I still will get a 0 right here because that's -2 times 0 squared. That's still 0. And so f of 0 is still 12. And then now when I plug in the 2, I'll get -2 times 2 squared plus 12. Doing the exponents first, that's a 4. Then multiplying the -2 gives us a -8. And then once we do -8 plus the 12, we do get 4. So there is the equation. And I decided to write it in function notation, but this could have been a y the whole time. And just because we do have this kind of middle term with a b, I am going to write it as y equals negative 2x squared plus 0x plus 12, just to show my b value. It's 0 for this one because the term doesn't exist. And then once I add a, b, and c, we do get 10 for today. So there's my answer. I guess we're all done. Hope you enjoyed. I'll see you tomorrow. Bye.